Today we will go over section 5.4, which is the derivatives of y equals sin x and cos x. So whenever taking the derivative of sin x or cos x, these are things that you need to memorize. So taking the derivative of sin x will give you cos x, and taking the derivative of cos x will give you negative sin x. So how I usually memorize it is one gives me the other. So whenever I take the derivative of sine, I know it gives me cos x, and whenever I take the derivative of cos x, it gives me the opposite sin x. But how I memorize that negative sign is I see that cos starts with c, which reminds me of cat, and cats are mean, so it just gives me a negative attitude. So that's just a way, if you guys want to memorize it that way, that works by me, or just memorize it in a way that when you practice it just comes with it. So one of the problems that we're gonna solve is the part A saying y equals cos 3x, and they want us to find the derivative of this. So in this case, I see that another way I can write this to make it easier on the eye is putting 3x into the brackets. This way I see that the cos does not involve only x, it's actually 3x, which we counted as this being in the gx form, right? In this case, when we're taking the derivative, what's going to happen, and what happened previously, was we took the derivative of the outside first. So what we did with the composite functions, if you remember, we took the derivative of the outside, we kept whatever is inside same. In this game it will be 3x, and then we took the derivative of inside, which this was gx, so it would be better if I just say gx. So this was gx, we kept the same inside, and then multiplied by the derivative of gx, right? So I will do the same thing over here. So when I have y equals cos 3x, my f function is cos. Me taking the derivative of cos, I see that it's negative sin x. So I will be saying negative sine, keeping gx the same, which is 3x. So I will be saying negative sine 3x, and then multiplying by the derivative of gx, which would just give me 3, because x to the power of 1 is just 1. So this will equal to negative 3 sine 3x, and that will be my answer. So for the second one, I see that it's not only sine x, but it's multiplied by the variable x. So because they're multiplied, I can see that I can apply the product rule in this case. So that would be saying taking the derivative of x first, keeping sine x the same, and then doing plus, and then taking the derivative of x, and then keeping the sine x the same. Oh, the other way around. So let me just write it down. So chain rule stated, let's say if I say x being fx, and let's say I said sine x is gx, then this is going to equal to y being taking the derivative of fx first, keeping gx the same, plus keeping fx the same, and then taking the derivative of gx. Now if I apply this to my given function over here, first I take the derivative of fx, which is x. When you take the derivative, x to the power of 1 will just give you 1. Now keep the gx the same, which is sine x, do plus, and then keep fx the same, which is x, and then take the derivative of gx. Is when you take the derivative of sine x, it will give you cos x, so you just write cos x. So that would be your answer. You would just be writing it in a way that is sine x plus x cos x. So that's it. So when taking the derivative of these ones as well, it's the same thing as I showed you guys previously. So for part A, again, I can separate this into saying visually, saying sine in brackets x squared, which I will see that this is my gx right over here. And what I need to do is take the derivative of the outside, keep inside the same, and then take the derivative of gx and multiply by it. So if I do that, that's going to be equal to, since my derivative of sine will equal to cos, I'll write my cos over here, keep x squared inside, the same, and then take the derivative of the inside, which is x squared. So my g prime x will be 2x because I apply the power rule, bring that 2 to the front, do minus 1 to the power, and that would what I would end up with. And then multiply it by 2x. So now I have as an answer y equals 2x cos x squared. Another way, this is the easy way for me, since we're already familiar with this one. Another way your textbook shows you is by substitution. So what it does is, instead of doing this, it says, let's say u, I'll do it with a different color. So let's say u equals to x squared, right? And it's basically saying, okay, let's substitute u in the place of x squared. So it's saying y equals sine u. So in this case, it's easier to take the derivative because it's in the form of sine x or sine u, doesn't matter what it is. But directly from here, you can just say, okay, my derivative for y would equal to cos u, right? And from here, all you need to do is take the derivative, also multiply it by the prime of u, and this would give you 2x again over here. So it's going to give you, when you put this back into u, you're going to end up getting cos x squared, and then don't forget to multiply it by your u prime, which would give you 2x. It's the same thing, you just do substitution. So it's up to you to use whichever one you want. If you feel like it's easier to do it by substitution, go ahead. I feel like it's easier to do it the first way. Same thing with the second one. Let's try the second one in terms of my way and their way. So for the second one, it's basically visually it's the same thing as for me saying sine x squared, because it's basically multiplying sine twice. So over here, I know that I can say, we did this before, I can say here as my gx, and my technically fx would be equal to, my fx would be x squared. So my x is at technically my gx. Since my fx is like that, what I do is equaling this to by taking the derivative of fx first and keeping the gx the same, and then taking the derivative of gx, which comes to the same thing I showed over here. So we first start with taking the derivative of the outside by bringing the two fronts by power rule, keep inside the same, sin x stays the same, do minus 1 to the power, which is 1, then multiplied by the derivative of gx. Since sin x, taking the derivative, will equal to cos x, that's it. So I ended up with 2 sin x and cos x. So for their way, what they did is they put u in terms of sin x. So they said, let's replace sin x as u. And they plugged that back in, saying that would equal to my u squared. So y equals u squared. Taking the derivative of this would equal to 2u, right? And then you have to multiply it by the inside, which is u. So you multiply it also by the u prime. So my u prime is technically whatever I put here. So it's derivative of sin x is cos x. Put whatever the u is in the place. So that would be 2 sin x times cos x. So it comes to the same thing, whatever you want to use. So these are the both ways. So this is basically saying the same thing I told you guys about. So let's say you're taking the derivative of y equals sine fx. So in that case, I said gx because the inside function, that's how we saw it before. So if you encounter anything like that, what you do is when you have sine, it will turn into cos, where you keep the fx the same and then multiply it by the derivative of fx. So same thing we did before. If it's the cosx version, then you put negative sign and then put the derivative as a multiplication. So for this question, it wants me to determine the maximum and minimum values of the function cos 2x on the interval 0 to 2 pi. So what's different about this is it doesn't directly ask you find the derivative. It wants you to find the maximum and minimum values. So in order to find these values, I know that in a graph, so if you think of this graph, and let's say it goes like this, I know in order to reach the maximum, it's at this point which my tangent is horizontal, which is 0, right? Same thing with my minimum. My minimum would be at this point where my tangent would be horizontal, aka my slope is 0. So I know I'm trying to find the derivative of this and equal it to 0, therefore I can get my maximum and minimum values. The first thing we can start with is actually taking the derivative of fx. So we did this before, so if you have cos 2x over here, in visualization wise, it means the same thing as cos x squared out of the bracket. So how do you take the derivative of this? Think of inside as gx again, and my fx is actually equals to x squared, right? And what we do when taking the derivative is taking the derivative of outside first, so taking the derivative of f, keeping inside the same, and then multiplying by the derivative of gx. If you do that for here, I'm going to end up with taking the derivative of fx, which is over here, will give me by power rule bringing this to the front, so 2 over here, keep x, therefore gx the same, so cosx, and do minus 1 to the power, which will give me 1, and then take the derivative of gx, which is cosx. So taking the derivative of cosx will give me negative sin x, and this will end up being negative 2 sin x and cosx. So finding this value doesn't only stop there. I know from my trig identities that 2 sin x cosx, right over here, equals to sine 2x. So I can actually write this down, so negative stays there because it's not in here in the first place, and I replace 2 sine x cosx by sine 2x. So my answer is going to be negative sine 2x. So now that I have my derivative, I can actually equal this to 0 in order to find what my maximum and minimum values are. So I'm just going to divide each side by the negative to get rid of that negative. So I end up with sine 2x equaling to 0. So now from here, I can actually find out what my maximum or minimums are. So if you think of the graph of sin x, I know sin x equals to 0 at points 0, pi, 2 pi, 3 pi, or 4 pi. It goes on like that, right? But since it's 2x, if I imply that as a graph, where my points are zeros are when x equals to 0, pi over 2, pi, 3 pi over 2, or 2 pi. And what I realize is it's the same thing as dividing these by 2. It gives me the same thing. So whenever you have like 3x or 4x, if you don't know the graph, you can actually take the graph of sin x. We know that it equals to 0 at x points 0, pi, 2 pi, 3 pi, 4 pi, whatever. And I can actually divide that by 2 to find that at x points 0, pi over 2, pi, 3 pi over 2, that my sine 2x actually equals 0. So from the values that I found over here, if I make a chart of critical numbers, so my x values are 0, pi over 2, 3 pi over 2, and 2 pi, I can put that back into my original equation to see where that corresponds. So if I put 0 for my x value for cos like function, I will get the value of 1. If you put into your calculator, or if you know the graph of pi over 2 back into cos 2x, you're going to end up getting 0. 3 pi over 2, we forgot to put pi in there, so I'm going to add pi over here. Normally pi needs to be in the middle. For pi, we will get the value of 1. 3 pi over 2, we get the value of 0, and 2 pi, we get the value of 1. So I know at points wherever it's at 1, those are my maximum values. Wherever we hit 0 is my minimum values. So now if it makes it easier, max value of 1 is achieved at x equals 0, pi, and 2 pi, and min value of 0 is achieved for x equals pi over 2 and 3 pi over 2. So this question is asking us to determine the absolute extreme values of each function on the given interval, and we need to verify the results with graphing technology, which I'll just put pictures in. So the function I have is cosx plus sinx. When we are finding the extreme values, I know they're going to be at a point where, let's say, the max is going to be this point, where the tangent, slope of the tangent, is going to be 0. My tangent is going to be horizontal. So I know automatically when they're asking for minimum or maximum, I need to take the derivative of this and then see what I end up with. So if I take the derivative of y, I know taking the derivative of cosx will give me negative sin x, and I know taking the derivative of sin x will give me cosx. Now, since I have the derivative, and I know the derivative represents the slope of the tangent, and I said already that I want my slope to be 0, so I can actually equal this to 0, which I can move in this sin x to the other side to end up with cosx equals sin x. So having the derivative where my cosx equals sin x means wherever these two intersect are my points. So when you actually draw y cosx, which is represented by blue over here, and my y sin x, which is represented by white over here, and I see that where they intersect is this point, and another point they intersect is this point. And I see that this, the first one corresponds to pi over 4, and the other one corresponds to 5 over 4 pi. So my points automatically I know are pi over 4 and 5 over 4 pi, or 5 pi over 4, same thing. So since now I have my two functions, all I need to do is plug in, if let's say I put the graph over here for my original function, but let's say I didn't know my graph, all I need to do in order to find which one is maximum, which one is minimum, is to plug the values back into my original function. So if I do that, I'm going to end up with y equals cos, let's start with pi over 4. So cos pi over 4 plus sine pi over 4. And that's going to end up with, when you put it into your calculator, make sure it's in radians, I'm going to end up with 1.414. So now before deciding, I know this looks like my maximum, but make sure you try it for the second one as well. So my second one is cos 5 pi over 4 plus sine 5 pi over 4. And there I'm going to end up with negative 1.414. So now I know that since this is my highest value, this is my maximum, and it's the positive, and I can verify with my graph that in fact it is my maximum point at 1.414, and I see that the negative value has to be my minimum value because it's negative and it's my lowest point. So I can verify that also right over here at 5 over 4 pi at a value of negative 1.414.